piecewise function. We're doing a piecewise function here. I'm going to use a couple of three of our basic functions. Okay, so f of x is going to equal x squared if x is between -2 and -1/2 inclusive. 1 over x, f of x will equal 1 over x if x is between 1/2 and 2. Not including 1/2 because, of course, wait a minute. Okay, this is a -1/2 here. Sorry. Okay, again, x squared if x is between -2 and -1/2, inclusive, including the endpoints. Between 1/2 and 2, including the endpoints, graph is going to be same as that of 1 over x. And if x is between -1/2 and 1/2, not including -1/2 and 1/2, because -1/2 is part of the interval where x squared, where the function has value x squared, and 1/2 is part of the interval where the value is that of 1 over x. But between these two values of x, the value of the function is going to be 2 to the x. Now, if I'm typing it out, that's why I have to type it, because I can't do this with a typewriter. Of course, you can always set it up to look this way, but that's a lot of extra time that doing this for all my courses I simply don't have. So, f of x then will be x squared from -2 to -1/2, including the endpoints. It'll be equal to 2 to the x from -1/2 to 1/2, not including the endpoints. And then it'll be equal to 1 over x from 1/2 to 2, including the endpoints. Okay, well, we start by simply drawing graphs of these functions right here. Now it's partly red and partly purple, but it was originally purple. Graph of x squared, and a graph of 1 over x here, and a graph of 2 to the x here. And you recognize these graphs. I hope you recognize these graphs, since they're our basic toolkit fundamental functions. Okay, now, f of x is equal to x squared for a while, but not for the entire interval from -2 to 2. It's equal to x squared just from -2 up to where x is -1/2. Well, right here's a point where x equals -1/2. We could actually put that here in a -1/2. Okay, it takes this value both for -2 and -1/2. Takes the value of x squared so that we have solid dots at the ends of this interval. Then it's going to equal, and you know what? Did I even do this right? You know, when I did this, never mind, okay. I'm looking up here, thinking these are in order. It's always good to put these in order from left to right. Sorry, I confused myself there. Thought I'd done something really bad. Okay, so anyhow, f of x is then 2 to the x between -1/2 and 1/2, but not including the points where x is -1/2 and 1/2. So we follow the 2 to the x graph from its -1/2, x equals -1/2 point, up to its x equals 1/2 point, and that's going to be indicated by the red segment from here to here, not including the endpoints, so we have open circles at the ends of that interval. Then we're equal to 1 over x, as x goes from -1/2 to 2. So we're not using this part of the 1 over x graph at all, but we drew it just in case. We drew this part, we don't use all of it, but starting where x equals -1/2, and of course the value here would be 1 over 1/2, which is 2. We have this point, and we put a solid red dot at that point, and then we go on up to here, and we should have a solid red dot But if I made one, it's awful dim at this point. Okay, so now eliminating all the extraneous parts of the curves, the part of the x equals y equals x squared graph that isn't in red, the part that's not included because it goes beyond the negative 1/2 and so forth, and then just the part of the 2 to the x graph that's included and the part of the 1 over x graph that's included, we get this graph, which ought to be self-explanatory. Then, and I guess that's all I have to say about it. Now all this writing that intruded on this graph, just ignore the white writing, but there's the graph. And of course you can label the axes and label points and so forth. Okay, now another example. I just started out with three straight line segments, one intersecting the y and x axes at the indicated points, another with endpoints at -8, -6, and -3, -2, and another containing the point 6, -5 with slope of 0.7. And ask, okay, can you construct the f of x form of that graph? Okay, well here it is, but how do we get to it? Well, this equation is easy enough. The equation of this line segment, we go through the point 0, 2, so the y-intercept is 2, and the slope is clearly -1/2. We have a run of 4 and a rise of -2 in this little triangle right here. So the slope is -1/2, the y-intercept is 2, so the equation of the line is y equals -1/2 x plus 2. This line goes through the point -8, -6, and -3, -2. I write the equation this way. Okay. If xy is a point on the line, then the slope of the line segment from -8, -6 up to xy has to be 4/5, the same as the slope of this segment. And of course the slope of this segment is 4/5. We could sketch a little fundamental triangle here and see that the rise of this triangle goes from -6 to -2, so it's 4. And the run goes from -8 to -3, so it's 5. So the slope is 4/5, 4/5. So I write it this way. You have all kinds of forms. You have slope-intercept forms, 2-point forms, etc. You can use any form you want. I find this more explanatory and more intuitive. But if you want to do it by memorizing a formula, I can't stop you. Okay? And maybe I shouldn't. That's up to you. Okay, so anyhow, we have this is the equation. If I multiply by x minus -8, then I have the 2-point form where this is the slope. But in any case, if I solve this for y, and you can do that easily, I get y equals 4/5 x plus 2/5, and that's the equation of this segment. Then this segment, the slope is 0.7, and we have the 0.6 -5. So y minus -5 divided by x minus 6 has to equal 0.7. Whichever way you want to do this. If you want to memorize the formula, okay. And we get, excuse me, when we solve for y, we get y equals 0.7 x minus 5.42. So, between -8, x equals -8, and x equals -3, including the endpoints, here's the equation. So here it is on the interval -8 to -3. Then between -2, which is this coordinate, and 6, which is this coordinate, between -3 and 6, between x equals -3 and x equals 6, not including the endpoints, because the -3 endpoint is part of this function, and the x equals 6 endpoint is part of this function, we have this -1/2 x plus 2. So that's on the interval from -3 to 6. And then we have this function for x greater than x greater than or equal to 6. And maybe I should have written that x greater than or equal to 6, but 6 less or equal to x means the same thing. So there we have it. So there's a demonstration of piecewise functions, and hopefully that'll clarify the question that was asked about piecewise functions.